In this video, I'm going to explain how to predict the products for an acid-base reaction when only the reactants are given, and also show you how to draw the proper mechanism. I have already written the necessary steps so we can easily go through each one. For the following acid-base reaction, predict the products and show the mechanism. So step 1 is to draw the proper Lewis structure. The Lewis structure, or the electron dot structure, shows all of the lone pairs in a molecule, and they're not always going to be given to you. So the first thing you need to do is figure out what the actual Lewis dot structure for this reactant is. So for this one, we have sodium and selenium. So we have a metal and a non-metal. So we know that this is going to give us an ionic bond. So we know that the selenium is, so we have one electron over here that's bonded to this ring, and we have one over here, and we've also got two lone pairs. But because this is an ionic bond, the selenium actually took the electron from the sodium, so it looks like this. And then on this side we have sulfur and carbon and hydrogen. So this is just going to give us the electron structure that sulfur would normally have. So for step 2, it says assign any formal charge and any partial charges. So since we said this is ionic, we know that this is going to have a full positive charge, and the selenium took the electron from sodium, so we have a full negative charge. And for the partial charges, which there's also the inductive effect, the more electronegative atom is going to take a partial negative charge, and the hydrogen, because it's less electronegative, is going to take the partial positive charge, which means that it's going to have an overall electromagnetic pull towards the sulfur. So now that we know which is our more electronegative atom, we can figure out which is our base. The base is always going to have a strong base will have a full negative charge, and that is going to mean that this is going to be our base, because these electrons with the full negative charge, to get stable, they want to deprotonate or take this proton away from the sulfur so that it can have a neutral charge. So if this is our base, this is going to be our acid over here, which means that that structure is going to lose a proton or hydrogen. So the first thing I do is start to figure out what my products are going to look like. Since this is going to take this hydrogen, we can draw the arrows like this. So we're showing how the electrons are going to pull off that hydrogen, and then the two electrons that are bonded in this structure are going to go to the sulfur. We have to draw them going to the sulfur and not the electrons, because it's the actual atom that's taking those electrons, not the other electrons. So now we have an H going to the selenium, so this is going to be replaced by the sodium. So we have H, SC, and then the ring. And now that we have this sulfur taking on those electrons, we have this structure. And since this has an extra electron, now the sulfur is going to have that full negative charge. So we can't stop right there though, because the sodium doesn't just get forgotten. So we have to show where the sodium forms in this. So since the sodium has a full positive charge, it's going to bond over here in an ionic bond with the sulfur now. So now we've shown how the electrons have deprotonated this molecule and given the electrons in that bond to the sulfur, forming the negative charge. So that being said, if the base is always going to be electron rich, meaning that it has a full negative charge, that means that this is going to form a conjugate acid. So since we have the base and our acid, now we need to figure out where the conjugate base is going to form. So again, full negative is going to form the conjugate base. And then we're gonna have our conjugate acid. So if we remember that the base is electron rich, and then the acid, we can say that it's going to be electron poor. Because again, negative goes to positive. So for this, we have these products over here, and just to be sure, just make sure we draw the Lewis dot structure, make sure everything makes sense. So in equilibrium, we should be able to also have the sulfur taking its electrons, this electron's going on and deprotonating the selenium in this side, which we would show coming from here and then giving the electrons to that, and we would get this exact structure over here. So everything in this equation is exactly as it should be. And since this is an equilibrium, these are both occurring at the same time. So we want to make sure that whatever we get on this side, we can use and make it so that we can get back to this. For equilibrium, we always want to put the position of equilibrium, which side the equilibrium is going to favor. It's always going to favor the weaker acid. So if we compare the conjugate acid to the acid, we know that acidity on the periodic table increases from left to right and from top to bottom. So we have CNOF, carbon, nitrogen, oxygen, fluorine, and then we have sulfur and selenium. So the more acidic atom is going to be selenium. So in this case, for these two, this is going to be the stronger acid. The conjugate acid is stronger because it's lower on the periodic table in terms of acidity. So that means that this is going to be the weaker acid. So we would get equilibrium arrows that favor the reactants. So for this mechanism, in equilibrium, the equilibrium is going to face the reactants. This is going to occur more often than this because this acid is weaker than this one. If you have any questions, please feel free to ask me. Thank you so much.